Volume of a solid with cross-sections. Okay, so what are cross-sections? A cross-section is the shape that we get when cutting straight into an object, like this right here. It's basically just little tiny slices of a solid. So that's important because if we can find the area of the cross-section, you can integrate it to get the volume of a solid. So when do you use cross-sections? The example problem will indicate whether or not to use cross-sections, as well as the formula for the region and the shape of the cross-section. It will also say whether the cross-section is perpendicular to the x-axis or the y-axis. So if the cross-sections generated are perpendicular to the x-axis, that just means that their areas have to be functions of x. So when you put in the volume equation, it has to be a function of x, and you have to integrate it with respect to x, and vice versa for the y-axis.
Alright, so our example problem. The base of a solid is the region in the first quadrant bounded by the graph of y equals x squared, x equals 3, and the x-axis. Cross-sections perpendicular to the x-axis are circles with the diameter in the xy plane. So they're asking what is the volume of the solid. So the first thing we're going to do is we're going to draw it out. So we drew it out here. We have y equals x squared, x equals 3, and the x-axis. And we have our cross-sections here that are perpendicular to the x-axis. So our cross-sections are circles, so we know that these are the diameter. So you're going to find that by doing the top, which is y equals x squared, minus the bottom, which is x equals 0. So you're just going to get x squared. But that's the diameter. And to find the area of the circle, we want to find the radius, which is just 1/2 of the diameter. So you get your radius as x squared over 2. So to find the area of the circle, which is pi r squared, you're just going to plug in the radius x squared over 2 into this equation. And then what we're going to do with that area is we're going to integrate it from 0 to 3 because those are your bounds. And you can actually, once you simplify this, you can actually take out pi over 4 because it's a constant to make integration easier. So then you get the volume is pi over 4 times x to the 5th over 5 from 3 to 0, which is going to simplify to 243 over 5. And when multiplied by pi over 4, you're going to get 243 pi over 20 units cubed.
The end. This has been Volume of a Solid with Cross-Sections by Hailey, Haymond, and Ronnie Shvueli.